Okay, so one last topic is about measures for a search engine. Since we have so many different search engines, how are we supposed to compare them? How do we know that which one is the best and why? And this part is to answer that sort of questions. Okay, to measure a search engine, we usually consider first these three aspects. Okay, how fast does it index? Is measured by the number of documents processed per hour. This is simple and quite easy to understand, right? And the second aspect is how fast does it search? When your user inputs a query, for how many seconds that we have to wait to get the result? That is the latency. On the other hand, it would be unfair to simply compare the latency values. That latency depends on the index size, right? For example, if you implemented your own simple search engine that only have like 10,000 documents indexed, 10,000 is considered a very small number, right? Of course, you can process one query in no time because the size of your index is so small. For a search engine like Google, they have like more than 1 trillion terms indexed. It probably takes a longer time to respond to a query. So certainly we won't seriously think that your search engine is better than Google's, right? So it's only fair to treat the latency as a function of index size and to compare the functions. So that's another aspect. And the third one is the expressiveness of query language. That is the ability to express complex information needs and to compare on the speed on complex queries. What does it mean? It means that first of all, for any search engine, the most basic function is I give you one word. You should be able to find some documents, some relevant documents that contains that word, right? And also, if I give you several words, you should be able to do the AND operation. And those are the simple and very basic functions. And what if, for example, I'm looking for the documents that contains the word apple, but I'm looking for the fruit, the real apple, not the company with the name Apple. And therefore, can I input something like Apple minus company? Can you do this for me? So that's an example of expressiveness. I mean, in how many different ways that I can accurately describe my requirement. And besides these three, there is the fourth aspect, user happiness. Well, so naturally the first question is, what is this? Well, in order to do some improvements on user happiness, certainly we have to know what this term means, right? So basically, in the context of a search engine, user happiness consists of two parts. One is the data retrieval performance, and the other one is the information retrieval performance. Data is different than information. Data means the raw data. It means to separate the terms from a document. So data retrieval performance evaluation means, first of all, we have to correctly obtain those terms from a given document. And then we measure the response time and the index space. That's part one. And part two is about information retrieval. Information is different than the raw data. It's not the term, but the meaning behind the term. So to do evaluation on the information retrieval, we are actually measuring the relevance. So to answer this question, how relevant is the answer set? For example, if I'm searching for the words red apple, we might get something about red and something about apple, and then merge them together, try to find the intersection. That is the documents that contain both words, both red and apple. However, in some cases, I might get some results like a red balloon in front of apple, where apple is the name of the company. So that's totally irrelevant to what I'm really looking for, right? So the information retrieval performance evaluation is to tell how relevant is the answer set. The relevance measurement requires 3 elements. First, a benchmark document collection plus a benchmark suite of the queries. What is a benchmark? Do you know? So the translation of benchmark would be 标准，是吧？标准集。It's like a kind of standard answer. So we have a collection of documents and plus a suite of queries. And being the benchmark means we know the correct answers to those queries. Then we're going to process those queries with our own search engine and compare our results with the standard solution. And therefore to obtain a binary assessment of either relevant or irrelevant for each query doc pair. So basically we're supposed to obtain a table like this. So for each query, suppose we have retrieved some documents and there are some other documents that are not retrieved. And we compare these documents with the standard solution and check out, count the number of relevant documents among the retrieved documents and number of irrelevant documents in the retrieved ones and also in the not retrieved ones. And there are 2 numbers we're supposed to obtain. One is called the precision and the other one is called the recall. And these are the 2 formulas to calculate them. But what do they mean? Well, say we have a whole collection of documents. This is the benchmark document collection. It's here. Okay. For each query, suppose that this is the standard answer. Okay. For that query, this is the set of all the relevant documents. And this is the result obtained by our own search engine. So what is a precision? The denominator is this one plus this one. That is the total amount of documents that are retrieved is the area of this red region. Okay, that is the denominator. And the numerator is this number. That is the number of really relevant documents that is retrieved, which is the area of this intersection. So precision tells us that exactly how many % of the retrieved documents are actually relevant. So it tells us the quality of this retrieved set. Okay, so if the precision is very high, it means that almost all the retrieved documents are really relevant documents. So precision shows the quality of your search engine in the sense that it tells how many % of the retrieved result is correct or say is relevant. But is it enough? Okay, think about this. What if my search engine only returns like one document and that one document is indeed relevant? What would the precision be? It will be 100%, right? Because I only retrieved one document and that document is 100% relevant. But can I claim that my search engine is perfect? Certainly not, right? So it's not enough to only consider the precision. And that's why we need the other one, the recall. The denominator is this one plus this one. That is the total number of relevant documents. That is the area of this green region, the green part. Okay, that is the denominator. The numerator is the same. Again, the total number of relevant documents that are retrieved, and which is the area of this intersection. So recall tells what? It tells how many percent of the relevant documents are actually retrieved by a search engine. So in the previous example, if I only retrieved one document, my precision would be 100%. However, the recall would be very low. And therefore, to really evaluate the overall performance of a search engine, it will be only fair to compare both of them, not just one of them. Okay, so here is a sketch of the curve relates to precision and recall. If we are at this corner, it means both recall and precision are very low. It means the performance of our search engine is really poor. Okay, and if we are at this corner, it means what? It means the recall is very low, but the precision is very high. Precision is close to 1 means what? It means that almost all the documents returned are relevant documents, but our search engine misses many useful ones too, so the recall is very low. It means we only return a small portion of the relevant documents. On the other hand, if we are at this corner, what does it mean? It means the recall is very high. However, the precision is very low. So at this corner, it means that we return most of the relevant documents, but at meantime, a lot of garbage is also returned. Okay, for example, say if by processing one query, let's return the whole document set, what's going to happen? And certainly, all the relevant documents are returned, but all the irrelevant documents are also returned, and therefore the precision is very low, although the recall is very high. What is the best situation? The ideal situation is at this corner, right? That is the ideal situation where both precision and recall are very high. It means that almost all the relevant documents are returned, and only those relevant documents are returned with no garbage. That's our target, but you know it's going to be very hard to get there. So our last discussion question is how to improve the relevancy of search results. This is actually an open question, and there are still many researchers working very hard to try to make improvements. Say for example, if I'm searching for red apple, how can you guarantee that all the documents you return to me contain the real fruit, red apple, and nothing else? So this is an open question, and so far people have tried techniques like PageRank by Mr. Page, and some other research areas like build a semantic web and more. And I believe you can find many research papers in this area. So go ahead and check them out if you are really interested.